me quickly introduce what extension means. If you must have treated the topic elasticity before, where you talk about the relationship between the force and the length of a material that can behave elastical in nature. Now the same thing is applicable to fluid. And then this application in real life situation enable insects to work perfectly or conveniently on fluid. But there are certain factors that can actually distract or stop this from being a natural phenomenon. Now what I mean is, if you introduce certain contaminants such as detergent or salts into a fluid or any liquid, this will reduce the tendency of this fluid to behave as if it is elastical in nature. So now what I mean is this. The surface of a liquid has a force which is being exerted perpendicularly towards its tangents from a point in that container where you have them. Now what I'm saying in essence is this. There is a natural case whereby the surface of a fluid, which is water, can behave like it is elastic in nature. I get what I'm saying. Most of you remember the case in the Bible where Jesus walked on water, and certain factors like the Archimedes factors, or probably the principle, which explains how the possibility can be for a substance to float naturally on water. So, but there is still a case study on that to be sure if truly Jesus actually walked on water. So now what I'm saying in essence is that, trust me, fluid behave elastical. And this elastic property is what we refer to as the tension on the surface. Now what I mean by the tension is this, is the applied force or the pressure on the fluid itself. Are we together? Are you getting that? Now let's take a short note, right? Because the marker is not here. Now right, surface tension is defined as the energy required. Surface tension is defined as the energy required increasing the surface area of a fluid. Increasing the surface area of a fluid. Increasing the surface area of a fluid. Now take that again. Surface tension is defined required as the energy required increasing the surface area of a fluid. Okay, so now you can see the definition itself. So it is something that is very, very direct, that you should understand what we are trying to say. Now in every respect or any case, we have energy involvement. Now this is what I mean. Hello, please listen to me. When you have a bucket of water and you place your palm on the top of the fluid itself, the only thing you notice is that the fluid from the surface will increase in size. True of us. So now it means that the surface tension itself is just brought about the effect of certain applied force on the surface of the fluid that brings about the expansion from the surface. I get what I'm saying. Do you understand what I'm saying? What I'm saying is this. If you have a bucket of water, for instance, okay, and then you apply a force on that surface, just lightly, not too much. What you observe is that naturally from the surface, okay, the fluid will appear as if it increases in size. True or false? True or false? So now it means that mathematically, surface tension is just the ratio of the applied force to the what? To the area. So now it means so are we together? Wow, your director is actually a scientist too. And I'm impressed. Well, yes, he actually gave me another real life situation whereby you can see surface tension taking place naturally, and this is what you do every day of your life. You carry out these practicals every day. In fact, some of you, before coming down to the center today, you actually did something related to surface tension. So another illustration is this. If, for example, if you have a glass of water and you have your pin or your tailoring, that pin, you just pour it on the surface, like you have about 5 of it. Do you understand? You just release it to the surface. Now what you notice is that from the surface of the fluid, there will be natural expansion. I get what I'm saying? There will be what? There will be natural expansion. Now that natural expansion is what we refer to as the surface tension. So now write in your notes that mathematically, surface tension is equal force over length. Force over what? Length. So now, hello, listen to me. Listen. If, for example, if I say, what does the statement mean? That the surface tension of a fluid is 0.30 Newton per meter. Newton per meter. Now what it means is that the fluid that experiences the surface tension has 0.30 Newton applied per unit length. That's what it means. Is that okay? Do you understand what I mean? What I mean is, if you say that, well, this thing is too loud. If you say that, what does the statement mean? That the surface tension of a particular fluid is 0.30 Newton per meter. What it means is that for every 1 meter, do you understand, the applied force, do you understand, to bring about the liquid to experience the surface tension is what? Is actually 0.30 Newton. Is that okay? Do you understand what I mean? Is it okay? Let me take that again. If, for example, if I say that, what does the statement mean? That the surface tension of a particular fluid is 0.30 Newton per meter. What it means is this. that the fluid itself experiences for every 1 meter 0.30 Newton force. Are you getting what I'm saying? Okay, please listen. How many of you have ever wondered this? That why is it that if you pour detergent inside a liquid, there are some properties of the liquid that we start reducing? Let me give you the simple illustration. In advanced studies, there's what we call colligative properties of a solutions that can be ideal or probably non-ideal in nature. Now, some of these colligative properties has to do with the boiling point and the freezing point, or the boiling range by temperature, or the freezing range by temperature of such substance. Now, what I mean is this. For example, if you pour salt on ice, what you are going to observe is that at some point, because naturally, particular substance. Now, which means that that particular substance may have what we refer to as what? A limited what? Expansion. Which one is much more lighter? Which one is much more lighter? Feather, right? Okay. Now, mosquito, ants, grasshopper, I group them as group A. Needle, nail, and also penis. I also group them as group B. Which do you think can
Baba, please remember to use your microphone.
Hello. Now, please look at the diagram on the board. Please listen to me. These are suspended particles inside a fluid, and then these suspended particles from what you can see on the board, from the diagram, you can see the arrow showing different direction. Now, this direction means the vector direction of the words of the applied force. Now, this shows that the different particles are actually having different directional effects on the fluid. Are we together? So now, which means that naturally, hello, look at the board, please. Naturally, this particular fluid behave in a way that it expands. Are we together? Now, this expansion is as a result of the force of effects brought by these three particles. So now, which means, look at the board, which means that the surface tension, or you can use the symbol, the surface tension is equal the applied force over the unit length. Are we together? So now that is the SI units of this tension will be Newton per meter. Simple. So you can have this in your notes. Surface tension is equal the force over the length. The SI unit is Newton per meter. So now therefore, we'll be talking about another basic property. Okay, so we'll pick a question. Then before we move to the advanced stage of it. Are we together? Now let's quickly take this very quickly. Right. Okay. There are two forces acting in the molecules of a liquid. There are two forces acting in the molecule of a liquid. Number one is the force of coercion, the coercive force. Number one is the force of coercion. That's the coercive force. is the force of cohesion. Now right, this act between molecules, this act between molecules, this act between molecules, this act between molecules, this act between molecules. Now please listen to me. When you write this act between molecules, on the line between molecules, that is the key word. Okay? So, or you can asterisk it, because that's the key explanation. Is that clear? The second one, adhesive force. Are we there? Adhesive force, right. Now, this acts between a molecule and the wall of the container. This acts between a molecule and the wall of the what? Container. This acts between molecules and the wall of the what? Container. Please drop your pen. I will take you through something very quickly. Drop your pen, please, and put your hands. I know that majority of you here, you know the meaning of force of cohesion and the force of adhesion. Adhesive force and cohesive force. But let me help you, okay? Let me throw more light. Now, the first one says that it acts between molecules that are the same, right? Now, what does that mean? For example, if you pour water inside a glass cup, if you turn the water out, okay, what do you observe? You are going to observe some of the remaining of the fluid, where? On the glass, right? Now, it means that the reason that particular molecule can attract the molecule of the glass is because there is force of attraction between them. True or false? Isn't it? Okay, so I'm going to relate it to how it's related to surface tension. Okay, now if you now check substance like mercury, when you pour mercury inside glass, what will happen? By the time you turn the mercury out of the glass, what will happen? Completely. Now you're not going to see any of the traces on the what? On that glass. What does it mean? It means that the molecules do not attract. Do you understand? It means that between the two molecules, there is no existing force of attraction at all. So now which means that, hello, listen to me, which means that naturally, every liquid, do you understand? Every liquid have two types of forces which they experience. Either you like it or not. So now it means that there are some fluid that cannot experience surface tension. Now why is it now possible for water to behave as if it is elastic in nature? The simple reason is this. It is because there is a force of attraction between the different molecules. That's what I'm trying to tell you. If there is no force of attraction between the different molecules, the expansivity, the expansion or elastic property cannot occur. Do you understand? I get what I'm saying. So now which means that from what you can see here, you can see that there are different directional effects that is brought through, that occur as a result of the what? Of the force of attraction between the two molecules in the fluid. Can you see it? Do you understand what we are talking about? Do you understand? Is it clear to you? So now let's assume that there is no force, there is no effect that is brought by the needle that you actually suspended inside the water. Sorry, inside the glass that contained the water. You know, there will be no effect at all. Nothing will happen. Do you understand what I'm saying? And so now, which means that, hello, listen to me, which means that naturally, every fluid must experience these two type of force. I get what I'm saying. So now, which means, okay, can I ask you this question, please? Everybody, please listen to me. If you suspend needle inside hot water, and you also suspend the needle inside cold water, what do you think will happen? When you suspend needle inside hot water, okay, and you also suspend needle inside cold water, what will you observe? We can be logical enough to tell us what will happen. Okay, let me add one more. And you have another glass cup of water that contain pinch of salt. Just pinch of salt. Then you have shake it. Then you now suspend the needle there. So what will happen in the three glasses? Yes? Anybody? Is there anybody who can tell us what will happen? Yes? Okay. Now let me quickly help you. We are going to relate this to what we call cubic expansivity or cubic expansion. Can you hear me? Okay. Now, do you know that naturally, when you are boiling water, okay, if you are boiling water, the first thing that happens is that the container gains the heat through a force and cause the fluid inside to start expanding as a result of the heat coming into the liquid, right? And naturally, what happens to the molecules? The molecules will start expanding naturally through a force. The molecules of the fluid will start expanding, Abby. And when the molecules of the fluid start expanding, what happens to the volume? Anybody? What happens to the volume of the fluid? The volume of the fluid will increase, right? Now, when the volume of the fluid increases, what happens to the surface tension of the fluid at that point? Yes? What I'm asking you is a very logical question. And this particular question, I think in 2015 or so, we have something related to that. That was asked by JUPEP and I think JAMB, they have also repeated such question before. Now let me help you. Listen to me. All you just need to understand is what is the effect of it on fluid. That's what you need to understand. Now, from the knowledge you actually got when you were thinking the topic expansivity, you did talk about cubic expansivity, true of us. Cubic expansivity and area expansivity of a liquid, right? Now that's where we tell you that whenever you are boiling, you apply it to the container. The first thing that will happen is this: the container will do what? It will expand through a force. Now when the container expands, after some time, the container will start returning back to the original size. You know why? Not that to the original actual size, but it will appear as if it is returning. Why? Because at that particular point in time, it is now losing the heat to the what? To the liquid. Are we together? Now, when the heat is now returning to the fluid, are we together? The container will start returning again. Now, at that particular point in time, the volume of the fluid will start increasing. And while the volume of the fluid is start increasing, the density will be doing what? Will be reducing. So now, if the density starts reducing, it means that there will be lesser surface tension experienced. Am I communicating? There will be what? Lesser surface tension experienced. So now, for the one that remains cold, nothing is happening. I guess what I'm trying to say. So at that point in time, there is moderate known density of that fluid, and therefore experiences more surface tension. Can you see the difference? And the one that has the suspended detergent or salt inside, the surface tension will do what? Will reduce. In 2008, WAEC question, if you go and check their physics question, there is a particular part where they used toy boats. How many of you remember the question? If you have your past question here, you can open it. You see where they put the toy boats and town for. Now you can see they were asking questions related to what will happen. Please, I want you to listen because we're going to learn a lot of things from this class. I will chip in from different questions that they've asked, even in your UTME. I get to that now. Go and check it. This is how the diagram appears. You have the toy boat like this. Let me see the toy boats. Look at it. So we have one for here. Okay, so where we have can you see? So I guess what do we actually asking them? If you go through your SSE PQ now, who have any YX PQ here? Anybody? Check 2008. You will see this question there. Anybody with YX PQ? Yes. If you have your YX PQ, open 2008 for physics. Have you seen it? Is it there? Go to the theory. You see the toy boats there? Something like this. Have you seen it? Hello? Hello, that boy. Have you seen it? No, 2008 there. Okay. Okay. So now, the hello. The possibilities. Hello. The possibility of the toy boats to move, okay, on the fluid without the camphor. Do you understand? Is because the surface tension is not reducing. But now we have a salt. What type of salt is camphor? Double salt, complex salts. Double salt, complex salts. What type of salt is camphor? Double salt, complex salts. Can't you talk? Double salt or complex salt? But you have done salt now, you have treated salt. Eh? Okay. Now the point is this. The presence of the camphor here reduces the surface tension. That is the point. That's what they are trying to ask them. You can see the natural phenomenon. If you get to, you can carry out practical, you can demonstrate this. You can try it at all. You see what will happen. So now it means that the presence of certain contaminants will reduce the surface tension. Now let's also branch. Let's look at this. How many of you know what we call hardness of water? What can make a water to be hard? Yes? The presence of what? The presence of what? What are the calcium and magnesium salts that can make a water to be hard? Lime what? Calcium what? The carbonate and the surface of the salt. Okay. Now, do you think water that is hard? Okay, hardness can be what? Permanent and what? Temporary. Which one can we use boiling process to reduce? We can use exchange of iron resin to which one? Our wipe slap. We can use exchange resin or the exchange of air. What do you say? To reduce what? To reduce entirely. It's fine anyway. Now what I'm just trying to explain is this. Please listen to me. Hello. Probably in your chemistry class you'll discuss more better than that. We are just trying to relate everything together so that you can get it clearly. Now listen. Listen to me. If you take any water that contains high amount of salts, do you understand? If you use it to, like you always use it frequently. Let's say if you have a cloth that's a colored cloth, let's say the type of cloth you have is maybe pink or colored one. Do you understand? And then you are using your tablet soap. You know what I mean? That's your bar soap, right? So most of the time, that's what you use. Use that water. If you observe, after a while, the cloth will start getting fade, like it will be fading up. Why do you think that is happening? Because the water you are using is actually tough. It is hard and it will waste more of the soap. True or false? And in the process of wasting more of the soap, there will be a substance called scum that will be formed. Are you getting that now? And as a result of that, that proceeds the chemical process. And so which means that naturally the surface tension experienced by the fluid, do you understand, to help pass through the cotton flow. What I mean is, when you put the water, your cloth inside water, what you don't know is that surface tension is experienced if you don't know. But the point is this: so that the wool will not absorb too much of water, you have to pour detergents, but it must be a soft water that is not hard, that does not contain high amount of salt. That's the point. I get what I'm saying. So now, as a result of that point, that fact, you must add detergents. Do you understand? And detergents contain a lot of emulsifier agents. But don't worry, don't let us go into that. Are you getting that now? So now those things help to reduce the surface tension. And conveniently, while the surface tension is reduced, what will happen? Conveniently, you can wash. Do you understand? And likewise, when you do like this, when you shake the fluid, what will you observe? You observe certain micelles that will be formed on the surface of the fluid. Now, when you look at them, when there is light intensity coming from any angle, shining on that particular micelles, you are going to see different colors that will be formed. True or false? Those things, they have tails. They have tails. You must have done something like that before in your under your organic chemistry detergents, right? So that's where you see more of the structures. Those things are existing organically. Do you understand? They have organic structure. I get what I'm saying. So what I'm saying is that the toy boats would not float conveniently or move faster as a result of the presence of the word camphor. That's what I'm trying to tell you, and that's what they're asking you. So if you get home, you can go check your PQ, or you surf the internet, check, you see, or you can just ask with your phone that 2008 theory question that has to do with surface tension. You see the diagram there. So what I've just explained is just the answer to that particular problem. So now the camphor there will reduce the surface tension. Are you getting that now? But listen to me, don't get it wrong. Don't get it wrong. Who can state the principle of flotation? What is the principle of flotation? Anybody? Okay, if you cannot state the principle of flotation, is there anybody who can state Archimedes' principle? Yes? Anybody who can state Archimedes' principle? Yes? Nobody? Yes? UTME students. Nobody can state Archimedes' principle. Okay, you are saying something. He said when the object is totally or partially immersed, Abby, in the fluid, what will happen? That's the upthrust which it experiences. Okay. Is equal to the weight of the what? Of the fluid display. Now, what is that fluid display? That is what? That is an expansion. Can you see that now? There's an expansion experienced at the surface of the fluid. Is that clear? Do you understand? Do you understand? So I've given you different situation, different phenomenon. So you should be able to understand what surface tension is, okay? So we'll still talk about what we call surface energy. What I call it? Yes, that's what we call surface energy, okay? Then we have a series of calculations on that, okay? So now take this. Let's proceed. Right? Leave a paragraph, just please write. Okay? Now, I want you to sketch this diagram. So I want to use the diagram to explain something.
can actually act this way. This way. Or whichever way you want it to go, depending on the direction of the force.
Okay, sketch this diagram. Okay. Have you done that? Have you done that? Okay. Or should I make it bigger? Let's make it bigger.
Oh, okay.
No, I want to make it bigger. So that I can show the direction of the forces clearly. You understand? So now this is the fluid. Okay, let's say this is X acting in different direction, displays. So let me show like this.
Okay, so you can see the different direction. So I just want to show you the effect of the force. That's the different direction. Okay, as the fluid is expanding at the surface. Okay, so now I'm going to use this to explain what we have here. That's the notes. Okay, so now let me show you something. So I'm just going to use this particular note to frame, this diagram to frame a note from here. Okay. Now the reason I'm giving you this diagram is for you to get a clear picture of what we are talking about. Is that taking? Now what you see here is just the direction of the force, applied force. Can you see? So we have three particles suspended inside the fluid. Okay? So now with different direction, I'll take this right. Okay? Right in case in case X, or that's the first one. Now right. The molecules experiences cohesive force only. 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 Okay? Or probably, hello, instead of writing in case A, take this one to be probably case Y or Z. Are we together? Hello, please don't. What I'm trying to do is this. I'm trying to make it much more clearer. Okay? What I mean is this. You know, one is very close to the surface. Okay? The other one is very close, like to the bottom. I get what I'm saying. So now the one here, you can just write, instead of writing in case A, or you can just write in case Y. Okay, just change it to case Y, because this one experiences, it acts in all directions. Do you understand what I'm saying? So this one is much more closer to the surface. That's what I'm trying to say. Just write in case Y. Okay? Okay. So now in case Y, it experiences cohesive force. I will explain it, don't worry. Are we together? Now right. Right. I said that what? Because what? Because what? I said because it acts in all directions. Because it acts in all directions. Because it acts in all what? Direction. Therefore, the net cohesive force is 0. Therefore, the net cohesive force is what? 0. Therefore, the net cohesive force is 0. Okay, please suspend whatever you're doing. I am not, hello, listen to me. I'm not confusing you. I'm just trying to make this much more clearer so that you can understand. Hello, listen to me. That case is clear. Okay, that case is what? Clear. Just hold on. Now, can you read the notes out together, everybody? Okay. Abi, because the force are experienced acting what? So you can see that. Is there anything showing that they are attracting? Is there anything showing that Y is attracted to the fluid? Sorry, to the container. Is there anything showing? Very good. Now I want to show you something. Look at the board. If I now remove this, listen, then I now remove this. Can you see? X and Z, are they acting in all direction? Do you understand what I'm trying to say now? What I'm saying is this. The picture which you have seen, the diagram which you have seen, shows that I gave this showing the forces in all direction, Abi. I also gave this one forces in all direction, Abi. So now which means if this one, if they are in all direction, they have a cohesive force. Okay, which total net summation that your algebraic sum, do you understand, will be 0. I get what I'm saying. But with the indication, without forces acting in all direction, the case will be different from the first case we have considered. Do you understand what I'm trying to tell you now? Is it clear to you? Hello? Yeah.
Hello, everybody, can you hear me? Can you hear me? Please listen to this announcement. Henceforth, you are not expected to leave the class for any reason to buy anything. There is nothing like I want to go and buy water again. If you want to buy water, or you want to drink water, or you know you need water, make sure you bought it before coming to the classroom. Is that taken? Nobody is permitted to leave the class at any point in time, henceforth. Once you are caught leaving the classroom, just conclude that you are leaving the school and you are leaving academics, you are not coming back again. So if you want to drink water, you know you will need water, come to the classroom with your water. That is number one. Number two, you cannot eat anything when the class is on. The only thing you are permitted to do is to drink water. Is that taken? You cannot eat anything when the class is on. The only thing you are permitted to do is to drink water. Thank you. Baba,
Now, can you see the clear illustrative diagram now?
Is it clear to you now? Can you see? So what I did is that I actually used this to explain what I'm trying to tell you. Are you getting that now? So you can see that from this diagram, okay? You can see that this guy inside the fluid, this guy is acting in all directions. Is it clear to you?
Yes.
Now I want to ask you, X and Z, are they acting in the same direction? Do you get the points now? So now for Y, it has what? The total net cohesive force is what? The total net cohesive force is what? So now sketch this diagram. Is it clear to you now? Do you understand what I'm saying? Okay. So now I'll give you case for X and Z. Okay. For case Z now. Are we there? For case Z. Right. For this one now, okay, KZ. Are you there? Right. This experiences both coercive and adhesive forces. This experiences both what? Coercive and what? Adhesive what? Forces. Because it is in contact. Because it is in contact. Because it is in contact. Because it is in contact with other molecule. Because it is in contact with other molecule. Because it is in contact with other molecule. Because it is in what? Contact with what? Other molecule. Because it is in contact with other molecule. Okay? Now right. And the what? And the wall of its container. And the wall of its container. And the wall of the what? Container. Now the last one is what? X. So for case X, right? For case X, this experiences coercive force only. This experiences coercive force only. This experience coercive force only. Are you there? Alright. Now, however, the net coercive force is not zero. However, the net coercive force is not zero. However, the net coercive force is not zero. Please underline that statement. Net coercive force, not zero. Underline. Net coercive force, not zero. Net coercive force, not zero. Net coercive force, what? Not zero. Now, right. Since there are no coercive forces above it, the net coercive force on X, the net coercive force on X acts downward, acts downward, acts downward, and this is similar to all the molecules. Acts downward, and this is similar. Acts downward, and this is similar to all molecules at the surface of the liquid. To all molecules at the surface of the liquid. Then write further. Write further. As a result of this, the surface of the liquid, as a result of this, the surface of a liquid, as a result of this, the surface of a liquid behave like a skin. Behave like a skin. And it is always behave like a skin, and it is always behave like a skin, and it is always behave like a skin, and it is always under a tension. That's where I'm heading. Under a tension. Under a tension called surface tension. Now, hello, please listen to me. Under a tension called surface tension, please underline surface tension. Underline surface tension. Okay. Now, everybody, please don't chew your tongue. Okay. Now, for the case X, now everybody carefully read it out together. 1, 2, 3.
Hello, please together. 1, 2, go.
Yeah.
Hello. 1, 2, go.
Experiences coercive force only. However, the net coercive force is not zero. Since there are no coercive force above it, the net coercive force on X acts downward, and this is similar to all molecules at the surface of the liquid. As a result of this, surface of a liquid behave like a skin.
Hello. Now, which parts? Hello. Which parts of the fluid experiences surface tension? That's my question. Which parts? Which parts among the three cases that has been shown here, where is surface tension experienced? Why? 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 That is why I said you should read out the notes together. Why is it experiencing surface tension? Yes? Hello? Why is it experiencing surface tension? Yes? Because of what? It's in your notes. Because there is no words. Because there is no words. So now it means there is an attraction between two different mole. Is it clear to you now? Very good. Now let's continue.
Now let's take this question. Right.
Write down this question, please. Of 2 Newton. A force of 2 Newton acts on a liquid. A force of 2 Newton acts on a liquid. A force of 2 Newton acts on a liquid of length 50 centimeter. Of length 50 centimeter. Determine the surface tension of this fluid or of this liquid. Determine the words. Determine the words. Now let me quickly tell you this. For those of you, I think I actually, was it on Saturday or on Sunday that you guys had your CBT practice? I think Mr. Sage was there, so I was just moving around and I saw a particular problem that has to do with that has to do with conversion. So I saw the young boy. He was just doing calculation. He saw the question and he just started writing. And I stood. I was looking at him. I said, so if you continue like this, you just do what you are supposed to do. What I'm trying to say is that as long as science is concerned, especially physics, physical science, listen to me. If you are given certain units, you're expected to convert. You're expected to do what? Convert. Though, after his calculation, one of the answers is there. And I was looking at the boy, I said, but I knew it's going. I think you guys always do review, Abby. You always do review, Abby. Like after, when you are done with the CBT practice, go and check your work. I guess that boy must have seen the reason I stood and I was looking at him. I said, are you okay? At this, you are preparing for UTME and you don't know that whenever you are given units, you are expected to convert. The units are kilogram for mass, meter for length, seconds for time. So naturally expected to convert. Now why am I bringing up this case? Because we actually have 50 centimeter, am I correct? And for 50 centimeter, you're expected to convert to meter. That's the fundament. I get to that now. There used to be a time that we have the foot, the palms, and also the inch. Okay, for measurement some time ago, but now we are in the modern age. Do you understand? So now let's convert this. So the first thing we are going to do is this. That's wave interference. Now listen. So now the first thing you're going to do is, for every problem you're given, solution, write out the expected formula to use. Surface tension equal the force over the length. Okay? If you want to proceed further, say the units is Newton per meter. So you are telling the examiner that when I'm done with my calculation, I'm leaving my final answer in this unit. But at times, if you don't even have the unit for the value which you're going to get after your calculation, you can also tell the examiner the same thing. Okay? So for the force applied, the applied force as given, or you can just write given. Given. You are given force, you can write in full. What's the force given? You are given 2 Newton. Okay, what are you given again? You are given the length, right? The length given is what? Is on 50 centimeter. Okay, but you can state that's if you are taking SSC exam, and this is part of the theory. These are the things you are expected to write at different stages to your examiner, because they check all those things through their marking guide. I get to that now. Okay, so now we say standard units for length. Standard unit for length is meter. Standard unit for length is meter. Therefore, length is equal 50 centimeter divided by what? 100, right? It's 100, right? That's 50 over 100, right? That's, you write it this way. Is equal this. So you are leaving it in the 0.5 meter. So you have actually tell them that, okay, for this reason, the standard norm for my length is always in meter. Are you getting that? Is it clear to you? Okay. So you can proceed using your formula to solve. So you say, therefore, surface tension is equal, the force given is 2 Newton, and the length given is 0.5 meter. So now class, when you divide this, what I expected to get, I think that's 4, right? So now that means the surface tension is 4 Newton per what? Meter. So now it means this is not new to your examiner anymore. You've actually made it clear to your examiner earlier that the unit you solve it with is actually what? Is actually in Newton per meter. So these are some of the things that you need to know. I get what I'm saying, they mark with steps. But most authors will just show you the direct process. And you know, for exam case, do you understand? That is why you see that listen to me. If the federal government decide that, okay, we want to make your UTME exam a written one, in theory, there will be a problem. Because part of the Nigerian A level is JAMB, if you don't know. JAMB is also Nigerian A level exam, if you don't know. Just like you have JAMB, you have JAMB, you have JUPEP. But the body that actually regulates, that works, you know, JAMB, they have their own exam. The exam is UTME. Abi. So if you are going to use paper, that's okay. We want all Nigerian students to take theory. But the simple reason the federal government will not do that. Hello, the simple reason the federal government will not do that is because it will cost them more. To cost the federal government more. Though CBT is a little bit cheaper. It's cheaper now, affordable. But even as that, they are not even spending more on their IT system. That's why you see that at times you can go and check your UTME result, you see 280. Tomorrow you see 180. And by the time you go and meet them, they will tell you it's computer error. That is a problem. We pray that God will improve the standard of our technology in Nigeria. It's not even a matter of amen. It's a matter of we working as a team. So to ensure the perfect results. Okay, now let's take another example. So I'm going to give you just a few minutes to solve that. I haven't understood this one. Okay, you have this already in your notes. All right, now take this. Okay. Okay. Okay, I've not actually gotten to this explanation because it's very technical. As that, let me frame a question from my head. Now, solve this. What is the surface tension experienced? What is the surface tension experienced by a liquid? By a liquid. By a liquid. By a liquid. By a liquid. If the applied force is 1/3 fraction, if the applied force is 1/3 fraction, if the applied force is 1/3 fraction, if the applied force is 1/3 fraction of the length, is 1/3 fraction of the length, is 1/3 fraction of the length, if the length is 150 centimeter, if the length is 150 centimeter, please be fast. If the length is 150 centimeter, what will be the surface tension experienced by the fluid as a liquid? What is going to be the surface tension? I know. Some of you will say that anything that is coming from my head is going to be strange. I do not know why you have that kind of belief system. Let that belief system erase. Another problem. So we are going to solve the two together. Now write this. Write this. Let me assume that JAMB asked me to set question under surface tension, and I now want to set it. I want to give you an example of what I can set so that you can understand. Are you getting that now? Oh yeah, right. The mathematical expression for the surface tension of the liquid is force per unit length. The mathematical expression for the liquid, for the surface tension of a liquid, is force per unit length. Is force per unit length. A liquid A experiences a force of 3/5 Newton. 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 And a length, and has a length of 5/3 Newton. Sorry, over 5/3 centimeter. 5/3 centimeter. Are we together? All right. The surface tension is the same as of liquid P. That of liquid P. That of liquid P. That of liquid P. Are we together? If the length is just 15/9, is just 15/9 centimeter, is just 15/9 centimeter in a simplest fraction. In a simplest fraction, what is the expected force? What is the expected force? What is the expected force experienced by liquid P? That's exactly the type of question you should give the UTM students to rack their brain and think of what to do. All right, you can solve it. So, okay, I believe those of you who are actually capturing from any part of the country, the essence of giving you this question is just for to know probably you are actually following up. Okay, it may look a little bit technical, but not too technical. It's just something you need to sit and look into it. So you can try the question now. Let's have a group discussion. Please be fast. So I know there's a random discussion now that have caused problem. I have actually caused no problem. It's just for you to think. I said the two of them experiences the same surface tension. So now we should mean that there are just too many whatever there. So it has been simplified. So I'm waiting.
Ayo, raise up your left. What is that? What is that? I'm doing it intentionally. Oh yeah, please, be fast.
So you can see that the problem is very, very, very simple. Okay, so we have just a few minutes because of those people who are joining us from that's online. So now let's quickly take solution to the problem. So the first, excuse me. So class, we have two problems. Okay, you are still tackling the problem. Are you still tackling the problem? What happened to the second problem? The answer is what? Okay, verify if that's actually correct. So now please, can you help us read out the first problem? Hello? Harvard. Can you help us read it out, the first problem? What is the surface tension? What is the surface tension? What? Hold on, please. Surface tension is what? The force over the length, right? Right? So now, which means that what is the force? What is the applied force? From the first problem, what's the applied force? 1 over 3RB for the force. Please, can you read out the question? I strongly believe that you are not taking wheat. What I said, yes. What is the force experienced? 1/3 of what? 1/3 of the length. Force experience is equal 1/3 of the length, right? Isn't it? What is the length? 150 centimeter. So length expectedly, the length is expected to be 150 divided by what? 100, and that's what 1.5 meter, right? So our force is what 1 over 3 times 1.5, right? 1.5, and that gives what 0.5 Newton. So normally I'm supposed to say 150 Newton, but I will mark you wrong. Mark it down with immediate effect, because I'm expected to tell me that the force should be the value of the standard unit. Are you getting that now? Okay. So now from here, what will be the surface tension? Surface tension will now be the what? 0.5 Newton divided by what? 1.5 meter. So what's the final answer here? 0. What? 0.3 Newton per what? Meter. So that's the first problem. Okay. So now the second one. What is the second problem? Surface tension is the force over what? Length. Surface tension of A is equal surface tension of B. Agreed? So now which means the surface tension, the force experienced by A over force length of A equal the force experienced by B over what? Over length of B. Am I communicating? So now which means that what do I have? The force for A is what? What's the force? 3 over what? 3 over 5. 3 over 5, right? Newton, right? That of this one is what? Wait, force here, force of A is what? 3 over 5 Newton. The length of A is what? Length of A is what?
5 over 3.
5 over 3 centimeter, B. Convert it to meter. What do you have? 5 over 3 over 100 will be what? Convert. When you convert, what do you get? 500 over 3. Is that what you got? Is that what you got?
Where do you get down?
500 over. Hello, to make everything easier, 5 by 3 is what? 5 divided by 3 is what? 1.67 divided by 100. What did you get? 0. What? 1.67 divided by 0. What? 0.016 Abi 7 Abi 7. Now 0.0167. Okay. Now if you now have 500 divided by 3, what do you get? Just 500 divided by 3.
166.67.
Do you understand what I'm saying? So now which means it's almost the same thing. You understand? Like what I mean is, when you finally divide, you divide by 100, Abi. Let me make it clear. So because of those people who are actually viewing. When you divide 5 over 3, you get what? 1 point what? 1 point what? 67, Abi. Approximately 1.67, right? So now 1.67 divided by 100, and that gives you what? 0.0 what? 167, right? Can you see that? So now for the force of B, that's what you're looking for, right? Then the length of B is given as what? 15 over what? 15 over 9 in its smallest fraction. That was what they said, Abi. They said in the smallest fraction. Smallest fraction is the same thing as 5 over what? 3. Abi. 5 over 3. And that will still give you, if it, by the time you divide it, you are still going to get 167 Abi in meter. True or false? True or false? Very good. Now, convert 3 over 5. Convert it to Newton. What do you get? 0. What? 0.6 Abi. 0.6 Newton. Can you see that? 0. What? 0.6 Newton, Abi. Isn't it? So now here you have 0.6 over, what's the length of A? 0.0167. Force of B is not known. Length of B is what? 0.0167. Then we do what? We cross multiply. So when you cross multiply, what do you have? Sorry, you have the force of what? Force of B, Abi, will now be equal what? 0.6 times what? 0.0167 over what? 0.0167. So this cancels out. The force experienced by B is what? 0.6 Newton. That's what you're looking for. So clap for me. I said you should clap for me. You didn't say easy. When I don't worry, let JAMB tell me to set your question.
Oh, that will never happen.
Eh?
That will never happen.
Why did you say God forbid?
I know why you said it.
But this is very cheap. And it is very straight. I've given you very straight and cheap questions. But I've not even given you technical questions. But I want to take you through a lot of things before giving you a technical problem to solve. Okay? I believe you are learning. You have not started anything. We have not started anything. This is just the beginning. This is just the beginning. What time is it now, please? All right. Okay. So I believe you guys understand this aspect clearly. Okay. So now let's move to this other aspect. All right. Leave a paragraph right. Excess pressure. Excess pressure, right? Excess pressure. As many as possible. I'm what? You said, sir, you're what? All right. So let me just wait.
No, this is the one. Sorry.
So I don't outside this one. So next question.
Let's move to excess pressure. Man. This aspect. Very crazy aspect. The aspect of excess pressure, very crazy. I will tell you some things here. Upper.
All right, let's move to the aspect of excess pressure. Leave a paragraph right. Those of you at the back, strongly believe we are together. Are we together? We are not together. You can do what? My writing is too small. You can't see. She said what? The last part, 0.6 Newton. Force of B is 0.6 Newton. All right, leave a paragraph right, excess pressure. There are two types of pressure acting on a liquid. There are two types of pressure acting on a liquid. There are two types of pressure acting on a liquid drop due to forces. There are two types of pressure acting on a liquid drop due to forces. Please, that reminds me. Please, I want to quickly say something. Hello, listen to me. Hello, please listen. I want to quickly take you through something that is it may be too self-explanatory to some people, and to some people it may not be self-explanatory. To some people it may not be self-explanatory. Are we together? Hello? Can you hear me? Hello? Sorry, excuse me. What is going on at the back? You can see? You can see? Hallelujah. Oh, that's fantastic. You can. You cannot hear me clearly? My voice is fluctuating. You mean you want me to increase the sound? You cannot hear my explanation. Hello? That girl, look at me. Look at me. Look at my face. Can you hear me? Please, I want everybody to sit right and please listen. I do not like distraction. The only thing that will enable you to hear me clearly is if your colleague decide to keep quiet, then you hear me. The class is divided already because there is not too much story chipped in, and you should know this is a live class. This is a live class. We have people seeing this from different parts of the world, and that's the truth. Not only Nigeria, it's a live streaming. Hello, listen to me. That is why, hello, that is why if you are online, you don't know. You don't know, maybe. Hello, listen to me. Anything that is online, I can be using the Nigerian WhatsApp number, but I'm not in Nigeria. You know that, right? So when I say you are seeing the video, you are seeing the live streaming from different part of the world, it is actually the truth. Any part of the world where they can access the internet, of course, yes. So now we do not want to waste anybody's time. Hello, please listen to me. What I'm trying to tell you is that, hello, what I'm trying to tell you is that currently now I am a sailor to some people's ship now. So I want you to please keep quiet and allow me to explain in detail. Now I said I wanted to explain something and I would not want distraction.
Yes.
I don't want distraction. Please listen to me. Okay. Now, have you ever wondered that why is it possible? How is it possible for us to have a type of what? I should move closer. I'm camera shy.
That's the point, sir. That's what we are saying.
So are we together? I think the same thing I'm saying is what was noticed. I told you this is online. So I wouldn't want you to distract what I'm doing. So please keep quiet. Thank you. God bless you. Now what I'm saying is this. Have you ever wondered that at times when rain drops, you hear sound as if stone, they are throwing stone. True of us. Like you just hear something like tuk tuk book book, eh? And at times when it is raining, you may not hear such sound. And if you are walking under that same rain, if the rain hits your skin, it will look as if they stone you. True of us. Do you know that this particular aspect explains what happened? That is why I want everybody here that is God-fearing and ready to shape their life appropriately should listen to me. This is exactly what happened. In a circle of water, there is a process which we refer to as evaporation. Now, this evaporation is as a result of the fact that most of the fluid on the surface of the planet Earth experiences a kind of escape in the conversions of their fluid types to gases. Now, water from the sea, from plants, from humans, from well, from the soil, everything escapes and they go form cloud. Now, when they form cloud, listen to me. When they form cloud, there is what we refer to as the range in density. And this range in density has a lot to do with the eyes. How many of you have entered plane before? Like you've traveled through plane. You know, hello, listen to me. What is, there is nothing special. There is nothing special if you have traveled through plane before. You can leave from Abuja, excuse me, you can be living at Lagos for Abuja and you pass through plane. Now what I'm saying is this: if you have experienced it before, you are going to see some parts that looks as if there are block form. I guess what I'm saying. Try enter plane, you understand. I get what I'm saying. Now, the higher you go, the more you will not see anything again. The only thing you will just experience or you just be seeing along different path is just cloud. Do you understand? And at times, if you see the way, if you see the way the clouds are formed, you see wind. Like the pressure of the wind, it is only God, do you understand, that secure the process where the plane is going. Let me just tell you the truth. So the pilots also work with their whatever. Do you understand? But it is actually scary. It's actually scary. That's why you see when some people just enter plane, they start praying that God don't make nothing, because that's the most scary type of transportation. Land is even okay, you can still jump. But for plane, child. Hello. So what I'm trying to eat as a point is that those things, when they start experiencing high pressure, it will start breaking and turn into water. But some of them whose density remains. Now what I mean is that some parts that has not totally melts, do you understand, that comes down. I get what I'm saying. They are still water, but not totally melts. Those are the ones that hits the surface as a droplet of blocks. And at times you may see this type of rain take place and block will be falling like snow. So that is telling you, hello, that shows you that, hello, listen to me. That shows you that to some point, science is very real. Science is very, very real. And all these things have been explained. That's just the process. And that is why you see that, hello, there is what we call Lauba. Lauba is just a region where two points connect. So if there is no connectivity between 2 points, rain can be dropping here and it will not drop the other place. You can just experience rain here to start dropping here and check the other side here. No rainfall. I get what I'm saying. Is it clear to you? Do you understand what I'm saying? So what I'm saying is that the liquid can expand and experiences pressure, and they behave elastical, and that is what surface tension. Do you understand what I'm saying? That is what a surface what tension. Are we together? Are we together? Are we together? Now right further. Right further. Right further. Now I said on a liquid drops, right? Due to forces, Abi. But now, which are internal pressure and external pressure? Which are internal pressure and what? External what? External pressure. Hello, are we together? Hello, are we together? Hello, are we together? Okay, so now it means that, like I said earlier, I said the pressure that is acting on the liquid drop. Now, what is the meaning of the liquid drop? Okay, what is the meaning of the liquid drop? Yes, is there anybody who can tell us what it means? Liquid drop. What does it mean? Eh? What is the meaning of when I say a liquid drop? What do you think it means? Eh? Ah, jeez. Okay, listen. Hello, listen. Please listen. Now, this is exactly what we're trying to say. The drop means a compression of the fluid. That the fluid is being compressed. So naturally, there's something we're going to see. Pressure is defined as the what? As the force per unit area. Don't say something. Don't listen. Are we together? Pressure per unit what? Area. So now, which means that the pressure excess will be the what? The differences between the pressure that is being experienced between the internal and the external. What I'm saying is this: as you're exerting pressure from within, pressure is being exerted from outside, and that is why ice block can melt. True of us, ice block can melt because there are external pressure now, isn't it? What are these external pressure? Atmospheric pressure. That's why if you want to experiment something, hello, if you want to experiment something, when you wake up very early in the morning, press your front teeth. You will see that it will be soft. Yes, you can try it. So imagine somebody just waking from bed and you just punch the person. You can imagine the bleeding. That tooth will remove instantly. Because at that point in time, it is very soft. Why? The reason it is soft is because what has been experienced is due to the atmospheric pressure. So now when you are asleep, you are tired, your mouth is open. You are so tired. And you know that most of the time, if you are tired, you snore. Or you can even experience what we call sleeping apnea. Sleeping apnea. There will be low volumes of air. That's when you see the person do like, that's actually sleeping apnea. That person actually need help. But you'll be like, sorry about that. Look at the way this guy is snoring. But you don't know that person is in danger. Some people die overnight like that, if you don't know. Some people just go like that. That's why you hear, the person, nothing happened to the person, the person slept, and the person did not wake up again. These are some of the causes. So please always take note of that. Is that taking? Okay, now let's write further. Write in your notes. The differences between them. The differences between them. The differences between them. The differences between them. The difference is between them, that is the internal pressure and the external pressure. The internal pressure and the external pressure. The internal pressure and the external pressure is given by the expression below. It's given by the expression below. Is given by the expression below. Change in pressure is equal pressure of the internal excess of the internal minus pressure of the external. Change in pressure is equal the pressure of the internal. That's this is the what you see here is called the pressure excess. What I call it? Yes, change in the pressure excess is equal the pressure, the internal pressure minus the external pressure. But everybody should take notes that pressure is equal force per unit area. That is, pressure is equal pressure of the internal minus pressure of the external. We are heading somewhere. Pressure is the excess pressure experienced internally and the pressure experienced externally. We can get the differences in the excess pressure by saying pressure experienced internal minus pressure experienced externally. External pressure and the internal pressure. Do you understand? So now, which means pressure is actually the ratio of force to area. That's pressure. That is the ratio of force to the what? To the area. So now, which means the pressure excess is equal P internal minus what? P external. Is that clear? Now let's proceed. We are heading somewhere. Okay? You have that already in your notes. Now write further. Write further. At equilibrium, two forces act on this liquid drop. At equilibrium, two forces act on this what? Liquid drop. At what? Yes, two forces act on what? Liquid what? Drop. There is something I'm actually trying to do. There's something I'm actually trying to do. Okay, now, hold on please.
Everybody suspend whatever you are doing. From this particular question, I want to form a formula. There is a particular problem here, but there is a formula to solve it. So I have to form the formula for you. Are you getting that now? So now the formula, the question is actually talking about the excess pressure of a liquid drop. But that's what I'm doing. I'm actually forming the flow from here. Of a liquid drop, I get that. Hello, listen to me. Hold on. Of a liquid drop from, hold on, please. Now, hello. Let me just look at it, okay? Okay. Please. Hello. Hello.
Hello. Hello, can you hear me?
Yes, sir.
Can you hear me? Can you hear me, please? Can you hear me? All right, please just look at the board. I want to show you something. I'm going to relate these two formulas. Okay, just please stay calm and look at the board, please.
For excess For excess pressure that is experienced, pressure is equal force over change in area. Now from here, from here, the experienced force can be equal to the pressure change in what? Area B. Now, for the excess surface tension, this is for the excess pressure, okay, as experienced. Are we together? Now, for the excess surface tension, force over the length. That is force is equal to force times length. The excess surface tension, but the excess surface tension is equal to the excess springing.
But the excess surface tension is equal to the what? Excess pressure that is experienced. Are we together? Excess tension is equal to the excess pressure that is experienced. So therefore, this is what we're going to have.
Can you see this? Let me see what the question says. Okay.
Now from here, we then have the pressure experienced, change in area, equal to the surface tension on the unit length. So from here, hello.
Excess pressure will now be equal to surface tension over length. Write this down first.
Hello, based on the particular question that we have there, I think they are talking about the change in excess pressure, okay? It's not involving change in area. So just put delta P here. Are you okay? Are we okay?
What I'm saying is this. I'm trying to form a formula for the question there. So here they are talking about change in pressure. So just make this one to be a change in the pressure. Are you okay? That's the same pressure, just like the formula I gave you earlier. P internal minus P external. Are you getting that now? So now make this one to be a change in the pressure. So now this one will not be changed in that pressure. You understand? That is the P internal minus what? P what? External. Will now be this over what? Over A. You understand?
Yes, sir.
To relate it with the particular question, that's the formula relationship, but it's not in the textbook. That's what we use to solve the problem. I've derived it. So there is a relationship between them. So just write down this relationship. So now this is the excess pressure. You understand what I'm saying? The excess pressure. Now this is the excess surface tension. So now, but the excess pressure is equal to the excess surface tension. You now relate the equation together. So from here you can get the excess pressure equal to the surface tension over what? Over the surface tension multiplied by the length over what? Over the area. So with this we can solve that problem. Is that okay? We can solve the problem.
So now let me see another one. So now let's look at something is a very cheap one. Are you done?
Yes, sir.
Are you done?
Yes, sir.
Okay. Are you done with this?
Yes, sir. Yes, no,
You see where I'm heading now. I'm going to be relating some things together to get some things. Are you okay with this aspect? Are you okay with this aspect?
Yes, sir.
You are okay, Abi? Very good. Fantastic. Can I rub this off?
Yes, sir.
Bring it.
Can I rub this off?
Yes, sir.
You are done writing this one now?
Yes, sir.
Eh?
Yes, sir.
Are you done writing this formula?
Yes.
All right. Listen. I want to rub this off. Then I want to relate something. Just hold on.
We are all fine like that.
Now, for the excessive liquid drop, listen to me. For the excess liquid drop,
Experience in circle. I get to that now. That it is circular. I get what I'm saying. The bubble, you know, it's like a circle, right? So now, hold on.
if you look at the circle, it has a point from here that is touching any part of the circle,
Yes, sir.
which is what? Which is the radius. Am I correct?
Yes, sir.
Am I correct? But don't forget, but change in the excess pressure is equal to the what? To the surface tension multiplied by the length over what? Over the area.
Yes, sir.
Now which means the length is assumed to be the circumference. That is, the length is equal what? 2 pi r. Circumference of the circle. Am I correct? Comma. The area is equal what? By what? R squared. Put it here. That is to say, change in pressure is equal to this multiplied by what? 2 pi r over what? By r squared. Am I communicating? This guy, we cancel this guy out. Out together. This guy, we cancel this guy. So therefore you have this equal this multiplied by 2 over what? Over r. My final conclusive formula will now be changing this will be equal what? 2 of this over is a phenomenon in physics. It's what? It's a phenomenon in physics. Yes, there is a particular problem.
We can use this to solve. Write this down. Write it down. I'm taking you somewhere. There are a lot of questions here, whereby I'm just studying the question. This is the formula approach. Are you getting that now? Right. We are heading somewhere. I said we are heading somewhere.
Don't worry. Brother. Can we progress? Can we progress?
No.
Excessive liquid. I'm heading somewhere. So, if it is now a drop bubble, if it is now a drop bubble, wow, a drop bubble, for a drop bubble, for a drop bubble, 2 layers, for a drop bubble, bring it. Hello.
So for drop bubbles, okay, if you're having excess bubble, this one is just a simple layer. And I want to check double layer. Double layer. How many of you know this formula in physics? Sorry, in mathematics, area of a ring. Area of a ring. You did all these things, well, I think when you were in Primary something. In your primary class, area of a ring. Hello, hold this.
Area of a ring. Area of a bigger part of the radius minus this. Area of a ring. How come I still remember all this?
Area of a ring. I think when you were in primary 5 or something. When you have a bigger part of the radius and a smaller part of the radius. So now you have a ring, the ring you put on. So if you have to cut it, you have a part that has a smaller radius and a part that has a bigger radius. But that's not what I'm talking about. If I have a double layer, what am I expected to do for the excess bubble with double layer? What is Dabbler expected to do? Please listen. Let's see. For excess layer.
Look at the ball. This is for a simple layer. For double layer. Where I have the same approach is what I'm going to use. Here, I already know that but this is equal. That is for a double layer. For double layer, I have two sides. So my length will now be equal to open bracket 2 pi r. Okay, and that will give me what? 4 what? 4 pi r. Agree or disagree? Agree or disagree? Now, where my area? But my area is what? By r what? By r square. My area cannot be measured in that way. Area is area. Because I'm dealing with the total measured size. So that's why I'm considering two double layers. Are you getting that now? So now for this reason I have change this is equal what? This multiplied by what? 4 by what? R over what? Over by r what? Square. This cancel this guy, this cancel this. Changing this will now be what? 4 what? So this will now give me the expression. What? Changing this will now be equal what? 4 what? Over what? See, that's for double layer.
Hello, please listen to me. You just need to follow everything that I'm doing. Okay? There are problems here where we will apply these formulas. So I have studied the problem and I've seen the formula approach. What we are expected to do. Are we together? Hello, are we together? Please, if you are confused, maybe probably the process for deriving this formula, can I see your hands up? Okay. Which of them? Is it the for the double layer or for the simple layer? For the both ones. This thing is very simple. When you have a double, hello, listen to me please. It is very simple, straightforward. You have water bubble, right? When you look at it, it's circle. You got to the surface, you're looking at the circular part. And then the natural formula which you've been given is actually the pressure, okay, which is equal the surface tensions multiplied by the watts, multiplied by the length over watts over the area. So what we just need to do as a mathematician, we just need to compare the length to be the circumference. Am I correct? The area to be the area of the what? Of the circle. And everybody know that the area of a circle is what? Is pi r square. But though I'm not taking you maths, if I'm assuming I'm taking you maths, I would have shown you the way the formula is derived. But we will take much time. And I would have also explained to you how the circumference, the formula is derived. Are you get what I'm saying? But area is pi r square. For the what's it called? For the circumference is 2 over pi r. Do you understand? So now where r is the length that shows from the center of the circle touching the circle at any point. I get what I'm saying? Hello, are you getting that now? So now all we just need to do is just to take the proper equation. Look at it from here. This guy represents circumference. This guy represents area. You cancel all through, and this is what you are left with. And that gives you this. The same thing happens here. Why we are having to multiply the 2 pi r is because we are having a double layer. I get what I'm saying. Double layer, that means we have 2 SS layer, 2 SS droplet of water. I get that now, the first bigger one, the smaller one. Do you understand? Inside. So now we are now taking the circumference of the two of them. That was even what led to the idea of the area of a ring. Because if you look at this thing is forming something like a ring. Can you see? We have a bigger radius and a smaller radius. But for here, based on the nature of the question we have here, I'm not going to advance to this point. But though, hello, I can still tell you that I can integrate this value. I can still integrate this value. Let me show you something. Do you have this in your note already? Okay.
Yes, sir. Can I rub this up? Can I rub it up? Okay. Can I rub it up? When I get to some parts that I'm using the volume of the spec, but I've not gotten to that part, just hold on. Normally my integral expression is this, where I have this as my constant. Hello, listen to me. Then I have this value, where my length is what? Sorry, 2 by r. I'm not differentiating, I'm integrating altogether. Where I take the value here, I'm taking the value of this one here. I want to actually integrate this value. Yeah, let me start with the first one. The first one tells me that I'm going to get 2 pi r1 plus 1 over 1 plus 1. My length will not be equal here on my drawing.
It is better you call me Damilare than to be addressing me as Mr. I feel offended. Okay? You don't call me Mr. It's not easy to acquire a degree. Are you getting that now? You either call me by my title or you call me my name. I feel offended to call me Mr. I have to be honest with you. Okay, now please look at the board. Now, hello, please look at the board. I am actually trying to integrate this value, taking you much more further than what we have actually experienced from the fundamental knowledge before we seen before. So now from here I have 2 of the pi, this giving me r square over what? 2. Hello, listening. Can you see what is happening here? Then I have this cancelled. My length is giving me r square. What do you say? Are you talking to me? I am showing the integral values of each that I'm given. So now the integral value of the other one that I'm given my area equal pi r square. So now for this, obeying this, I'm having pi r2 plus 1 over what? Over 2 plus 1. Am I correct? So I'm having my a equal what? Phi r raised to the power of 3 over what? Over 3. So I'm having 1 over 3 pi what? Pi this. Okay? Now the question I want to ask is this. Hold on. What did I call this thing? Area B, pi r square B. When I integrate it, what did I get? 1 over 3 pi r cube B. If I integrate it, I will get, yes, now this pi r cube over 3 is the same thing as this. Abi? True of us? Now, hold on, don't distract me, please. Area times height is what? Area times height. Volume is equal what? Area times height, Abi. Am I correct? Am I correct? Now, if I say by integral value, I'm going to get 1 over 3 pi r cube times height. Abi, it is no longer a volume. Isn't it? Is it volume? If I multiply area, this area times height, are we together? By this integral value, I'm not going to get the volume of a cone. Am I correct? What's the volume of a cone? 1 over 3 pi what? Pi r square what? 1 over 3 pi r square what? Pi r square. So which means that I actually checked. Look at the board, please. The length here is given pi r square from here. This is what I have when I integrated this. Now let's see further. By integral. By integral. So class, at this point, if we want to divide, what are we expected to do? How do we divide this? R cube. Wait, what I want to get is this. My no space have been mathematics very well. Is this process correct? This R this divided by R cube this equal this R this times 3 over this. Is it correct? Yes. Now, after this final process, you are going to get 3 this over what? Over what? Abi? R raised to the power of what? 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 This is R square here. This is cube here. So when this and this cancel out, what are you left with? 3y over what? By integral. By integral expression. But for this level, I don't think we have any question related to this. God will help all of you. God will do what? The same God that helped me will help you. So, Well, I have actually shown you the view part of this, and for that reason, I still have to take you much more deeper, as this is a surface. Let's go deeper. Hello. That right. Consider a stamp bubble of radius 15 millimeter. Consider a stamp bubble of radius 15. A stamp S-T-A-P, stamp bubble of radius 15 millimeter. If its surface tension, oh thank you God. If its surface tension of 0.05 Newton meter, 0.05 Newton per meter, determine question number one. Are you there? Yes. Question number one. Excess pressure in the stamp bubble. 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 Question number two under that. The internal pressure of this. The internal pressure of this. The internal pressure of this. If the bubble given that its external pressure is its external pressure is 1.01 atm, that's atmospheric pressure. 1.01 atmospheric pressure. Are we there? Is it 1.01 atm? Yeah. Have you done that? Have you done that? The external pressure, determine the internal pressure of this if the bubble given that its external pressure is, determine the internal pressure of this if the bubble given that its external pressure is 1.01 atm. 1.01 atm. So you can solve now. I've given you the whole process. Try it, then I'll solve it. Determine the what? The external. Why are you confusing me? I said determine the internal pressure of this. If the bubble given that its external pressure is 1.01 atm.
Can you take the question again? Ask your colleagues don't ask colleagues. Listen to me. Okay, listen.
determine the internal pressure. Determine the internal pressure of this if the bubble given that its external pressure is, if the bubble given that its external pressure is 1.01 atm. 1.01 atm.
So 0.01 and 1.01 atm. That is the last thing in the question. You want to get into a mistake. You will solve it.
What is the way you do that?
Level 55.
That's 4 minutes.
55.
I think this 1 atm is 1.0, 1.0, times 10 is 5. 1.01 that's 1
So I'm going to solve this now. Sorry about that. I need to take a few minute break so I can relax. I've been standing for a while. Yes. Listen. So now let me quickly solve this problem. So after this, we'll come to the end of today's lecture. Okay? So let me quickly resolve that. I've given you the expected formula to use. I told you that from the question I'm seeing, that this is the expected formula that you're expected to use to solve it. This is what you're supposed to do. Think. Hello?
Look at the board, please. For the question number 1, the 3 bubbles have been. Yes. Number 1, SS force. SS pressure. Yes, I will wipe his back. He's bubble now, SS bubble now. SS bubble. How does it relate with the I've shown you the formula now. When I do 2 bubbles now, yes, sir. That's what they are saying. Read out the question. Yes, I don't answer this. How many formula did I give you? I gave you 2 Y.
And this is the formula to use now. Read the question. What did they say? That's what I'm saying now. For the star bubble, that means that's the double. It's double. Hello, listen to me. Hello, listen to me. listen to me. There is one thing that is very funny, and it is very, very funny. I took my time to explain that of a circle, just a simple bubble, right? And I told you that when it becomes double. Now read it out. So now which means a star bubble, which means they are telling you that it is double, not single, not like a simple drop. You understand? So that's why I'm using this formula. I've derived the two formula. Okay? Now let's progress. So we have XX pressure, right? Which is equal what? This over this. Now what is this value given? Hello?
Surface tension is given as what? 0.5 Newton. 0.05 Then you are giving this as what? Abi now. Abi, you divide by 1,000. So now what do you get here? Excess pressure will be what? What do you get? 30.3 Abi. 8 Abi. So, hello, listen to me. You are given something here which I need to correct. Let me check the value which were given as your ATM. You are given in what? Newton per meter, Abi. That's for pressure, Abi. You are giving your pressure in Newton per meter. Let me check it. Is that what you are giving it? Check the value now. This one is given in Newton per meter. That's what I want to verify. Not so, which means this one would be in Newton. Abi. This one is not. This one is given Newton per what? Newton per meter. Abi. Yes, sir. So this one is given in what? External pressure is given in what? Newton per what? Abi, I hope you understand what I'm trying to say. Yes, sir. That's the pressure. But recall that this guy is equal what? Minus what? Abi. But 1 ATM is given as 1.013 times what? Newton per what? Meter. And you are given what pressure there? 1 point what? Okay, that would be, let's say, if you want to convert this one to Newton per meter square, this would be 1.013 times 10 to the power of 5 times 1.01. We are operating, what do you get? When you operate, convert this one to Newton per meter square. Convert it, what do you get? If 1 ATM is this, then this one will be multiple of this. What do you get? 1 what? 1.02 times 10 is power of what? 5 times 10 of 5. Are you sure? Are you sure? Are you sure? Okay. So now, therefore, what are we looking for? What they ask us to look for? External what? External pressure. That means internal pressure again. That means the internal pressure will now be equal excess pressure plus what? So that would be what? 13 point what? 13 point what? Plus what? Are you sure this value is correct? Yes, sir. We add it together. That is it. To be calculated. fún mi calculator. Value yẹn correct. Yeah, mo by multiply. Mo value yẹn correct. Then no standard value. Let me use standard value. Let me just use standard value. No, it's the same thing, but let me just use standard value. It's not going to give me the exact value that I'm looking for. Part of their options there. So if I'm to use standard value, let me convert it. Multiply it by 105. Just multiply it by 105. What do you get? But multiply it by 105. You will get 105. Multiply it. Give a random value. Multiply this thing by 105. Be fast. 1 was 1.4. 1.76. 106.3. 106.3. Keep quiet. Now, hello. Hold on, let's correct the value. You are the one giving me nonsense answers. We are helping multiply this. I multiply this one by 1.01. Don't disturb me. Leave me. You are using calculator. You are giving rubbish answer. 865. Help me add it together with this one. One. Which means the essence pressure is too much. Give me calculator. Rubbish them. Sir, 120. I'll start from the beginning. Most of you don't have this calculator. Yes, sir. Sorry, please. Hello, give me that mic.
Sorry, please. They are giving me wrong values.
Yes.
I have to start the calculation from the beginning. See, most of you, the EXP there means exponential. Most of you don't know how to use calculator. And in the end, you are giving me rubbish value. Just please hold on.
Hold on, please. Hold on for now. Hold on. I know that you pass out. You are using calculator. You are using
I was not going to. Why did you? I was going to give you
That's what you're saying. That it's supposed to be 133.33. It's correct. What she said is correct. I just said it right now. Most of the time, if you are using calculator, most of you don't know how to use calculator at all. You just be giving me wrong value. Nonsense. Oh yeah, from here now, let me correct. What is? Oh yeah, right. None of the options. Are we there? Oh yeah, if we convert, hello, if we have 133, okay? If we have 133, are we there? Yes, sir. 133.33 Abi. Yes, sir. Now we now want to convert it to the standard units as given here. What we were given earlier was in Newton per meter for surface tension Abi. Well, now let's now use in standard units, in standard unit format. So for standard unit format, we now have change in the pressure. This one is 0.2 Abi. Yes, sir. We have been divided by 15 times 10 to the power minus 3 fast. So to get the random figure, we have fast do that. 1.33, sir. 1.33. You are not alright. Let me start it off. It's supposed to be. Yes, what did you get now? 15 times. That one was 1.5, eh? 13 point what? 13.33 That's what I'm saying now. This one is going to be the shut up everybody. Hello, listen to me.
Listen to me. I have seen a very clear fact that with the use of your calculator, there is a very big problem. I'm telling you. At this level, are we expected to be teaching you how to use calculator? You are disturbing me. Because just for you to give me a very simple value. Now the point is this. On a random figure, converting this one supposed to be 15 multiplied by this. So I have checked it from the aspect of multiplying this by another value, 0.1. So I'm supposed to read and come to and get 13.33. This is going to give me my standard value. So now which means at that point, my change in excess pressure, I get that now, should be 13.33 Newton per meter square. Abi? So now if this is 13.33 Newton per meter square, and I am given 1 ATM, what is 1 ATM? If you have to convert it to Newton per meter square. 1 ATM is equal how many Newton per meter square? Jesus.
Hold on. Hold on. Please look at the board, everybody. Yes, sir. 1 ATM is equal to 765 millimeter mercury. Then in Newton per meter square, 1 ATM is equal to what? Yes, sir. It's us.
Hello. God will see us through. I said God will see us through. It is quite funny and unfortunate that at this point some of you don't know the standard given values in Newton per meter square. I'm afraid that's very dangerous. It is very what? Very, very dangerous. That at this level, you don't know how to convert to your Newton per meter square. You can measure pressure in Pascal, pressure in millimeter mercury. You can measure pressure in torr. Am I correct? So at this level, you don't know what 1 ATM can mean for Newton per meter square. So do you mean among everybody here, there's nobody that knows what 1 ATM can be for 1 ATM? One what? Do you mean everybody here? Nobody knows what 1 ATM can mean? You said what? What are you showing me? What are you showing me? Yes. 700 and what? 1.1 what? 1.013. So now you know after checking Google. Okay, you remember that I told you already. So because I've given you the answer earlier, and that is what will you allow me to talk? I gave you the value earlier, and yet up till now you don't even know what I mean. Hello, I'm going to tell your director something. Upon my next visit or my next engagement with you guys, I want you to go and write out some things. Listen to me. I want you to go and write out all the values as a constant and their units in values. Planck constants, values of Armstrong constants, decibel constants, all those things. Okay? I actually want you to go and get those things. What is that? You are saying what? Keep quiet. So you can even see it from there. You are on your own. When you enter the exam hall, you start dragging all those things. Wallahi, it's not funny. God will help you. Alright, now you know. Help me multiply 1.01 times the value of 1 ATM to Newton per meter square fast and give me the answer.
Be fast. Now, get the value that you were given. You were given the value of the external pressure, which is 1 point what? We are comparing this one to Newton per meter square fast. If 1 ATM is equal to this value, multiply this value by 1.013 times 10 to the power of 5 and give me the final answer here. Yes? 1 point. No, I will slap you. Stop that. Stop giving me values that are wrong. You see, multiply this one by the expected value 1.013. Yes, and multiply it by 1.01. What do you get? 1 0 2 what? Is that what you got? That's what you have at the Newton by what? Now I bring it here. Add it together. What is the change in pressure? Starting with what? Plus 1 0 2 3 1 3. We are add together. What do you get? Don't use this nonsense, Harry. Yes, what did you get? 1 0 3.6 0.33. Is that what you got?
Very sure. Very sure.
I don't have problem with you. My problem is calculator. How you use it. Go and learn how to use calculator. I'm tired of that.
This one, God.
Yes, sir. This is our work.
So thank you so much for your time. God bless you.
Still people watching all of thank you for all of us. Still people watching all of us. Thank you. Sọ́kọ́ tó ṣe. What am I doing?
No, they will outfit themselves. No worry. Come on.
People from all over the world. 5 lines. All of them. Thank you.
My friend, get out. I'm going to
How will I remove this one?
Yeah, let me see you if you want, bro. Yeah, see you if you want. Hey! You have not cancelled the live. I don't. The class is gone. What do you do? That I say,
And then...